Don't expect your home to pass the first time out, especially if it's the first time for a build team and a design team. It's just unrealistic when you're trying to hit a passive house level of airtightness the first time out. Doesn't matter if you're stick building or modular building. Anticipate failures.
Welcome to the Passive House Podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House Podcast.
Hello and welcome back to the Passive House Podcast. I'm Matthew Cutler-Welsh, coming to you from Belfast in Northern Ireland, and I'm joined by Mary James. How are you, Mary?
I'm fine, but a little envious that you're in Belfast. I'm sure.
Well, yes, I know. I was looking forward to seeing you here.
Yeah, unfortunately, didn't quite work out for me, but I get to listen to the conference virtually at least.
Oh, okay, great. So you're going to be attending some of the sessions virtually because they are offering virtual sessions. I think that's been pretty well attended this year.
Yes, I'm looking forward to hearing them.
Yeah, so I am very fortunate to be here, courtesy of some of our wonderful sponsors. And I will be covering some of the activities. This is I think they're quite excited about it too, because this is a joint conference with the Passive House Trust of the UK and also the Passive House Ireland as well. And really excited to hear some of the speakers and talk about what's going on in this part of the world and see if we can't learn a thing or two from things that are happening here in Ireland, but also great things happening in Scotland and across England as well. So,
Yes.
And meanwhile, our other colleagues are on their way to HERS Con, which is happening right at the same time. It's exactly the same time. So Zach and the team at Ilka J are heading off to HERS Con this week. So as this podcast airs, they'll be there in amongst that as well. So lots going on in Passive House world. But more about that. So let's get into this week. We've got a great interview to bring you. But before we do, I'd like to do a quick shout out to our sponsors and supporters, including our stakeholder partner, NYSERDA, and founding sponsors 475 High Performance Building Supply, Ingui Architecture, Hartel, Rockwall, and Zola Windows. And thanks to our champion sponsors, Buizo, Cascadia Windows and Doors, European Architectural Supply, Facro, Icon Windows and Doors, Intelligent Membranes, LG, and Source 2050. And a special thanks this week to Intelligent Membranes, who is our sponsor of the week. And they are among the people that I'll be looking forward to catching up with in person in the next couple of days, because I did chat to the team. Adam and the team, I think, is going to be here in Belfast. All right, well, let's jump in to this week's interview. And Mary, who are we listening to this week?
He's Tony Lisanti, and he's the managing director of Integral Building and Design, and he's been a QA/QC manager for Phius, and very experienced from energy rating through to Phius rating and verifying and everything in between. So he has a lot to say.
He does, and he does another background of all those acronyms and various organisations and ratings that he's involved with. So here he is, and we'll jump in after this conversation.
So, welcome to the Passive House Accelerator podcast. And I am very excited about our topic and our guest today. So, we will be diving into different rating systems for high performance and passive houses, what they are, how they work, and what it takes to be a rater. And our guest is Tony Lisanti, and he's the managing director at Integral Building and Design and the QA/QC manager for Phius. He has 39 plus years of experience in the energy and engineering field and 23 plus years in the building science field. He provides services for certifying homes and multifamily buildings for energy code compliance, HERS rating, stretch codes, Energy Star homes, Indoor Air Plus, WaterSense, U.S. Department of Energy Zero homes, and Phius. So welcome, Tony. So happy to have you.
Thanks for taking interest and having me in.
Awesome. So, well, this is all very impressive already. Can you tell us about the work you do?
Well, the primary work that we do, the core of it focuses around something called a HERS rating, right? HERS is a acronym for Home Energy Rating System. It falls under the umbrella of ResNet. And just full disclosure, there's a lot of acronyms and abbreviations in our industry. There's no shortage of them, so I'll do my best to try to bring some clarity to it. But ResNet is the Residential Energy Services Network based out of California. And they produced, wrote, and continually update something called the National HERS. It's a somewhat formalized method to model and verify the energy efficiency of a home, of a dwelling unit, which it could be a dwelling unit in a multifamily, it could be dwelling units within a townhouse, could be a single family detached home. That's the overreaching standard setting body, ResNet. They have a number of standards for how we conduct business, how we do inspections, how we do testing, how blower door testing, as an example, is to be conducted, how duct leakage testing, how we measure ventilation, how inspection protocols are to be carried out on the job site, data collection. And all of that goes into a formalized energy modeling software. And they write the standards for how that software works and how the calculations work. And there's several platforms that you folks have probably heard of. RemRate was probably the most robust for many years. A newer, more web-based software, Ecotrope, has come on the market in probably the last 5 or 6 years. And that seems to be the majority of the market now. And then there's another platform called Energy Gauge, which is more Florida-based. There's supposed to be standard methods of calculating what's called the HERS index or the HERS score. And in essence, what it does is it compares the home that you're modeling or that you're evaluating to a standard reference home and measures the difference in performance and improvement and yields a score. The lower the index, the better. And that's where we get the term, net zero to some degree. It's a zero energy ready home based on the HERS index. And so a home built to the 2006 model energy code or energy code that existed back then would have a HERS index of about 100. And then anything that you improve, that score would drop. So someone under the 2018 or the 2021 IECC would probably get a HERS index of the 50 to 60 range, depending. And then from there, you evolve into some of the voluntary federal programs, and that's what the HERS rating process is used for, is to validate certification for the Energy Star certified homes or multifamily program. And for the Indoor Air Plus program, although that's not a performance-based program, that's an indoor air quality program, but more prescriptively driven, but the standards are still used to validate what goes in the home. It's not a modeling exercise. It's more of a checklist-driven, specification-driven program. And then from there, you get into the Department of Energy Zero Energy Ready Homes program, where you would expect a home that's renewable ready to have a HERS index somewhere in the 30 to 40 range without renewables. And then when you add renewables on, of course, that index would drop. They want the purity of the HERS index without renewables in it. What is it before you put renewables on? And the lower, the better. The process is also used to validate energy code. So pretty much any state or any municipality that has adopted, I believe, either the 2015 or later, certainly the 2018 or later IECC, there is a third path in the residential chapter of that for compliance. We typically had the prescriptive path, which many architects are familiar with. You do a res check, you do all the mandatory requirements, put in the minimum insulation values, and you get the green check from a res check analysis, and you're good to go for your plans. The second was this sort of modified performance energy cost pathway, but they added what's called the R406 Energy Rating Index path, which is in essence a HERS rating process used to validate energy code. Numerically, the energy rating index and the HERS index are not quite the same. There's some differences in the way they're calculated, but they correlate fairly closely. There are a number of places in the US that actually use that as validation. Massachusetts, as an example, there's a couple of pockets here in New York State, a couple of small municipalities that use that as well. So that's the HERS rating in a nutshell. Now, Phius, as a high performance building standard, relies on all of the voluntary federal programs, the Energy Star, Indoor Air Plus, and DOE programs, as a means of ensuring the quality of their builds. And so they require a HERS rating for their single family townhomes as eligible. When you get into larger multifamily, there's a couple of other pathways, but they still rely on the programs, the Energy Star, Indoor Air Plus, and DOE programs. And under those programs, you might not actually be doing a HERS rating. They have different paths too. They have a prescriptive and they have an ASHRAE path, but they still require a HERS rater to do the field verification work and do the data collection and testing under the ResNet standards. And the beauty of it now is that the codes recognize these ResNet standards. Portions of the ResNet standards have actually been modified and written and approved as ANSI standards. One in particular is the ANSI ResNet ICC standard 380, 2022, which determines how you conduct a blower door test on the dwelling unit or a single family home. When you're hearing people talking about you're doing a 380 blower door test, that's what they're referring to. And it also has the methodology and the requirements for doing duct leakage testing on heating and cooling systems, measuring airflow from ventilation systems and exhaust systems. All of that's are in these standards. And so because they're ANSI standards, the codes can point to them and lean on them. I kid people that when I got into this in the early 2000s, we had the ResNet standards, but you didn't have all these other standards. It was just kind of like put a blower door in, do a single point blower door test, put a HERS model together with one of the softwares. Life was simple. It used to be fun. Now it's very technical. As HERS raters, our industry, we're the ones that try to interpret that for both the builder, for the design professionals, oftentimes the developer and homeowner of the project, as well as the code officials.
Well, that was a really great overview. And with all these complications, yet you added on another one, which is being a Phius rater or verifier. How did you get interested in Phius? And I'm curious how much of your work nowadays is doing Phius verification.
Becoming a Phius rater is actually training above and beyond what a typical HERS rater has. There is a formalized training regimen to become a HERS rater. There's both classroom training and mentoring that's required to become a HERS rater. And then Phius, as a standard setting body, has its different professional certifications. They have certified passive house rater, which is really intended for training valid HERS raters, people that are already HERS raters in the industry. They earn that badge so that they can work on single family homes and duplexes. That's what the Phius rater does. The title verifier is basically for everything else. Verifier allows you to work on multifamily projects and non-residential / commercial projects. And there's a little nuance in there. There's a multifamily designation, whereas you don't need to be a HERS rater to be a Phius verifier for strictly commercial projects because there's no HERS rating in there. You still have to conduct the tests under the same standards, but there's no formal certification to the Energy Star and DOE programs for a commercial project. We lean on those programs and treat them as if you're going to certify, so you pull elements out, but there's no requirement. You have to be a rater as a prerequisite to be a multifamily verifier. So to answer your question, how did I get into it? Passive house is not a new concept. As a rater, we've been doing this since like 2022, 2023. You always heard about passive house stuff, and you always thought that, well, that's weird masonry house with the canted windows that you overheat in the winter, and then the concrete kind of gives some of that heat back when the sun goes down. And it was this weird thing. And then it became more, I'm not going to say mainstream at the time, but it became more of a conversational topic. Fast forward, an architect that a good client of ours that we work with here in the Hudson Valley, New York, River Architects, I'm sure you know James Hartford and Juhi, right? They started getting into this, and they experimented with a SIP panel house up in Phillipstown, New York, about 45 minutes north of where I am now. And they started speaking this passive house language and designing these really beautiful contemporary homes with passive house principles. And they did this one house as an experiment, didn't certify it, but it was certified to Energy Star and Lead for Homes, and got really intrigued. They came across with a second home, which is basically a complete gut rehabilitation of a home right down the hill from their office in Cold Spring. And they wanted me to be the rater. I was not a Phius rater yet, so I teamed up with a colleague of mine, Pasquale Strocchia, who's in our New Paltz office, and he was a rater. And I basically told him, listen, I'll do all the field work for you, basically for free. I just want to learn how to do this, because James was already my client. We ended up teaming up. We ended up validating the home and skinning our knees, rolling up our sleeves and doing all the hard work to get it across the finish line to get it certified. And we did. From that, the builder, James, and I, over just venting and doing some lessons learned, we decided to form a Passive House Alliance chapter, at the time Hudson Valley. And the three of us founded that chapter. More James, I've got to give credit where credit's due. He was really the brain and the visionary with this. He was kind of letting me hang on his shirt tails a little bit. So we founded the chapter, and guess what? We found a lot of interest in and around the Hudson Valley, all up and down, and NYSERDA and everything else. And it grew. That chapter now is a New York State chapter. It's one of the biggest ones in the country. And we had people, homeowners, builders, subcontractors, HVAC professionals, many architects, engineers, really just coming to meetings just to learn about it. Fast forward, I've got now about eight or nine projects certified under my belt, including a commercial building, a multifamily modular constructed building, several single family homes. Some were renovations, some were all new, some were panelized, some were stick built. And we've probably got about 6 or 8 more in the hopper that are in construction right now. So that's how I got it on the professional side of things. Around 2018 or so, then quality assurance manager for Phius. This is when projects were really going into review for Phius. They would have maybe 1 a month or 2 a month. It was very much on the shallow part of the slope in terms of their increase in built and certified passive homes. Chris at the time, who was a principal at Building Efficiency Resources, the Bear, which is a big QA provider in the United States. He was the QA provider. For whatever reasons, he and I have been colleagues, friends for many years. He thought I was either good enough or dumb enough to take over from him as the QA manager for Phius. I'll let you decide which. So since 2018, about the fall of 2018, I stepped into the role of quality assurance manager for Phius. The title officially is not quality assurance manager anymore. It's senior building certification consultant. They changed the title about a year or two ago. It started out basically as I was the sole reviewer of all the incoming final certification work prior to the certification team looking at your final WUFI model from a QA standpoint. Are all the photographs there? Do we have good insulation photographs? Do we have good measurements out in the field? Is the blower door test valid? Do we have all the checklists for all the associated programs? That sort of thing. It became very clear to me that I was going to be a funnel point for the tsunami of projects that were going to come in. And so helped Phius staff up and got their folks trained to be able to do some of the reviews. I, at a distance, provide a lot of technical support to them now. I'm not actually reviewing projects day to day. There are some things that come up that they need me to weigh in on and be a referee on or make a judgment call or a decision on. It's still a very small percentage of our overall work at Integral Building, but I probably spend about 20% of my time working on passive house projects, either for Phius as their consultant or working on our own projects. We're seeing more and more interest to it. More folks are coming to us as energy consultants saying, yeah, what's this passive house thing? I want to build a passive house, or I want to put an addition on. I want to get it certified as passive. So I'm happy to hear that, because 5 years ago, nobody was having that conversation.
Amazing. So we definitely want to hear a little bit more about the projects that you're working on, but I'm curious about what does it really look like to do the final part of certification? Because I think most of us are more familiar with the design certification part, with the energy modeling, with WUFI or HPP and air sealing details and all of that the architect does and that the builder needs to be familiar with and work through. But then as a passive house consultant, which, the work that I do a lot of times, I basically then just pass it on, right? And then I do know that there are the checklists and someone needs to go on site to check the installation levels and all of that. But I, to be honest, don't really know what your work really looks like. So can you talk a little bit more about that?
Yeah, so it's funny you mention that, because to a large degree, there are many passive house consultants that it's like a sandwich. Passive house consultants, the bread, the QA piece is the kind of the tasty stuff in the middle. Many passive house consultants, they'll get through the design certification piece and then they step back. Now, if they're an architect and a passive house consultant involved in the project, then they're a little bit more engaged along the way. We have many passive house consultants that are basically just providing the initial analysis. They're doing the modeling. They're getting through design certification. Then during construction, they take a step back and they wait to hear from the field, from the architect and the engineers, from the rater or verifier, as to whether or not any changes occurred. And if any changes occurred, then they're reevaluating them in the WUFI model and PHPP back in the day and seeing if you're still meeting all the targets. And at the end, you're taking all the as-built conditions, the final values for verified insulation values. Did something change? The blower door numbers, the actual power measurements from ventilation systems, et cetera. And they're putting all of that into the model, and then it gets submitted for final certification. And a big mistake that a lot of teams make is that the verification, the rating and verification process is something that occurs at the end. It doesn't. It has to start at the beginning. And the best advice I could give, whether or not you're doing this for code or whether or not you're doing it for a fully certified Phius project, you need to have the rater engaged at the beginning of the project, at the design phase, before your construction documents are completed. And the reason for that is, okay, you can deal with all of the insulation values, the window detailing, the air sealing details. It's how you bake in all of these other programs, like the Energy Star program and the Indoor Air Plus program and the DOE program. There are a lot of things in there that often get missed in the planning and design phase. Like, you have to have balanced ventilation, but how much ventilation? Power consumption's an issue. How is that ventilation system connected to the home? Where is it? The insulation details on the ductwork, the vapor barrier details on that ductwork and how they connect to the vapor barrier, the air barrier of the house. Okay, there's information on that in the guidebook, but those are the little details and crumbs that are get often missed. There's actually a whole process of vetting the HVAC design that the rater has to go through for the Energy Star program. Okay, there's a design review that needs to take place, a formal design review. And you don't want to do that when you're under construction. You really want to do that before the plans are really put out to bid or before you file for a building permit, because oftentimes there'll be some small changes or some significant changes as a result of this review. And you don't want to have a permit set out in the hands of the builder or out for pricing when changes are made, right? That's when confusion reigns and when costs go up. So ideally, you would have a plan review completed by your rater or verifier prior to you submitting to Phius for your design certification. And Phius is now looking for some of these key things that are included in the design when it's submitted to them, like some of these preliminary HVAC design reports for Energy Star as an example. Okay, now footnote, these federal programs, Energy Star and DOE, are under the microscope from the federal government. We don't know what the future holds for these programs. They've been in place for decades. The Energy Star program predates me. That comes from the late 1990s, before I was in this industry. But those programs are under the gun. For today, right now, July 2025, they're in place. The advice that I could give, get the rater and verifier engaged early. When you submit a Phius project for design certification, you need a letter of intent from the rater or verifying company, or they won't review it. Now, we all know that oftentimes that design certification submission doesn't go in sometimes until after footings are being poured or excavation, right? Ideally, no shovel would be in the ground before that project starts. This becomes more of an issue with multifamily, affordable senior housing, that type of thing, because the construction schedule, the process has already taken maybe several years to get to the point. And so there's a mad rush to get the project built because of funding, because of closing dates, et cetera. There's a lot of pressure on these projects. So it's quite common to have a project being reviewed as it's being built. Not that that's the best place to be.
You mentioned senior housing, which I imagine you're thinking of a particular project, because I know you worked on a senior housing, Lamora.
Correct.
Can you tell us a little bit more about that?
Before we jump into the Lamora, I think it would be really interesting to just really quickly touch on the importance of those programs and certificates, because I think when I get asked about why is a certification important, and I think for me the big thing is that it sets up this framework, even if you don't at the end go through full certification, but it sets up a framework that lets you compare different buildings in one level, because everyone talks about doing energy modeling. All the software, Revit, on whatever you work with, has integrated energy modeling. But unless you set a standard, it's not really comparable. I was just curious to hear what you think, what the importance is there, and why we should really keep those programs around.
Yeah, I mean, the evolution of the Energy Star program, as an example, because that's probably the more cumbersome one to deal with. It's the thickest of the three programs, really. Early on, it just dealt with the building envelope. Okay, you want to air seal. When I first got into it in version 1 of Energy Star, there wasn't even an airtightness requirement. You just did a blower door to measure it, but there was no ACH or CFM per square foot requirement. It was just measuring. They had a bunch of prescriptive things in there, but you had to have some type of mechanical ventilation. You had to have a certain percentage of high efficiency or high efficacy lighting. The EPA looked at that and they said, okay, the next frontier, what's missing now in high performance building? And the Achilles heel had been and still is in many ways the HVAC systems. The sizing, number one, poor sizing, oversizing, still persists today. Maybe not so much in the passive house world, but in the rest of the world, it is certainly an issue. And so by adding design requirements and summarizing the design, the HVAC design, and then having a rater review it, doesn't guarantee perfection, but it does put a second set of eyes on it to say, did you respect the sizing disciplines for the heating and cooling? Does the equipment match the loads reasonably well? Is the ductwork layout done reasonably well? Okay. Included in the HVAC design, did they use the right insulation levels? Did they use the right window levels? Did they use the right occupancy levels? Did they use the right ventilation rate? Did they use the right infiltration rate in their heating and cooling loads? It's very easy to tell whether or not they didn't, because the numbers just don't match up with what's on the plans of the window schedule. That's some of the checks and balances. So it provides a level of quality assurance and quality control on the front end and the design end. And then as you go through the build process, you're validating and verifying things like the insulation levels, the thickness and depths, the quality of the insulation, the quality of the duct systems. You're going out and you're measuring duct leakage. Some of the checklists that we have for the Energy Star program force you to look at the ductwork and make sure that ductwork is not crushed. There are no sharp bends, kinks. The air can move from the air handling equipment to the outlet with ease, the way it was designed. Okay, is the ductwork laid out the way the engineer drew it, or the way the contractor drew it? Did they have to relocate some ductwork or resize the ductwork? How many returns are in the system? Are they oversized or undersized? So that was one of the big Achilles heels of overall building program. Again, it still is. Couple that with the ventilation strategy, because you could have a ventilation system, a balanced ventilation system in a home that meets code or meets Passive House, but how effective is it? What does it really do for the occupants? Okay, you just have an air moving device, but is it really providing the right amount of airflow? So we actually measure that. Okay, is the incoming airflow and the outgoing airflow, are they balanced? You're putting the house under a positive or a negative pressure due to imbalance because of ductwork layout and design. We check those things. Okay, we're doing duct leakage testing to ensure that thresholds are met with the heating and cooling systems. You don't want leaky ductwork. The air can get from point A to point B where it's supposed to go. You say to yourself, if you put ducts in a conditioned space and they leak, so what? Well, it becomes very difficult to balance the system properly if the ductwork leaks. And that's true for a ventilation system as it is for a heating and cooling system. But Energy Star really focuses on testing of the ductwork for the heating and cooling system, not so much for the ventilation system. They make us measure the ventilation system. There's also a balancing and commissioning requirement. Now, one of the nuances with the Energy Star program is that there's an HVAC commissioning checklist for single family homes. For multifamily, they call it a functional testing checklist, because that deals with common areas and central systems in larger buildings. It's recommended but not required that those get collected on the single family homes. Okay, so if you have a contractor that you've worked with and you could trust, one of the things that we've instituted at Phius is that under no circumstance do we not recommend getting the commissioning checklist. We're of the belief that if you don't ask for it, you don't verify it, it doesn't get done. So Phius always requires these commissioning checklists to be filled out by the contractor, submitted and reviewed by the rater. If you don't ask, you don't get. Okay, so that's one of the ways Phius is above these programs in terms of their quality assurance requirements. None of these programs guarantee that you're not going to have a problem, but it certainly removes a lot of the craziness that's rife in our industry with HVAC contractors not being disciplined with the design, with the installation. It formalizes it so that you get out of the system what you pay for, or as close to it as you can. Now, the second program, the Indoor Air Plus program, that deals with indoor air quality. So if you're in a radon zone, for example, we verify that you're putting in a passive or an active radon mitigation strategy in the home. We also review many of the materials that go in the home. We're in one of these in-between times when we have an outgoing version of Indoor Air Plus and a newer version. The newer version is a little bit more robust and a little bit more involved than the older version. But the bottom line is we want to make sure that the materials that go in the home, composite materials, plywood, sheathing, subflooring, etc., engineered lumber, the OSB that's used for I-joists and cabinetry, things like that. If it's a man-made composite material, we want to make sure that they're meeting federal standards and are meeting certain, in some cases, VOC guidelines. Paints, finishes. If you happen to have carpet and carpet padding, that's in there too. The newer version now includes insulation in that conversation and drywall. You have to check these things, okay? Qualitatively, it also ensures that wet materials are not being installed. We all know that a lot of things get stored outside. We all know that the building envelope sometimes isn't completely watertight for many months. We want to make sure that wet materials are not being concealed behind the walls. And the house is properly aired out, it's ventilated before occupancy. So that's some of the quality control that occurs. As I said, the bread, the top of the sandwich and the bottom of the sandwich, these are some of the things that happen in the middle with these programs. You have this design review, you have these qualitative and quantitative inspections and reviews that occur during construction. At the end, all the checklists get filled out along the way, along with the Passive House, the Phius QA workbook, checklist. It shouldn't be a heavy lift when you get to the end of the project. And at the end of the project, everybody's focused on one thing. Everybody wants to know what the blower door test is, right? That's the big nail-biting, dramatic thing. Phius recommends on any project that a midpoint blower door test is done. That's a whole nother conversation about when that should be done, what condition the building envelope should be in when you do that midpoint test. Under the Phius prescriptive path, which is used for more compact single-family home designs, it's mandatory that you do that test. You don't have to pass it, but you have to do it as a means of quality control. Our business practice at Integral Building and Design, we always do a midpoint test. We try to make sure that we do it when the building envelope is completed, windows, doors installed, everything taped, everything air sealed, even the mechanical and electrical penetrations into and out of the building envelope. We want those installed as well. We don't care what's connected to it on the inside. We just want the penetrations through the air barrier installed and sealed. We'll conduct the test. Hopefully it passes. Gives everybody a level of reassurance. And then we'll pressurize the home and we'll do some diagnostic work. We'll bring in a fog machine and pump the house with a theatrical fogger and a smoke pencil. We'll look for leaks, because even though the home passes, it's still not completed. Were you just marginally passing? Were you just marginally failing? Or were you way under? If there's an opportunity to fix some hidden leaks that would be extremely difficult to fix when the home is finished, that's an opportunity to identify them and then let the builder deal with it before drywall goes on. Our goal at Integral Building is that when you get to that final test, there's no drama. People don't even care about it. It's just a test. That's the way we try to set it up. We know projects don't work out that way, especially the larger multifamily, more complicated projects. They get more notoriety at the end because oftentimes you don't have the ability to test the entire building on a big project at midpoint because of the scheduling pressure. Okay.
That was really interesting on your La Mora project, right? Because it was actually modular. So that was a whole different process.
Completely. Depending upon the type of modular, in this particular case, that's true box modular, where the boxes come out of a factory and the interior finishes are about 90% done. In other words, the windows are installed, taped, the drywall is on, cabinetry is installed, light fixtures are installed, oftentimes switch plates, interior doors are hung, maybe the base molding and the final flooring is installed, but there's a lot that's concealed. Now, when you're building a 5-story building out of 96 boxes, in this particular case, they used a rater and a verifier in the factory to do some of these on-site inspections. And he did an excellent job. His name's Pete Vargo. He's worth mentioning. He's one of my colleagues out in Pennsylvania. If it wasn't for him, that project never would have gotten to where it was. It was his tenacity in working with the folks at Signature Building Systems. The quality control that took place in the factory when they shipped the boxes, we had a high degree of assurance that the stuff that's hidden was well done. Okay. But how does that equate to a whole building test? You can't test the whole building with a bunch of boxes, especially when they're being stacked. So they married 2 boxes together, covered up the roof and covered up the floor assembly. And they did what would be best described as a compartmentalization test. Each box was half of an apartment, a chunk of corridor, and another half of apartment. So when they married the 2 boxes together, what you got is a complete apartment, about 12 feet of corridor, and another apartment on the other side of the corridor. And so they tested the entire box, and then they tested each apartment, and they got good numbers. Not the first time. The first time they had some miserable failures, but they were able to identify some things, some additional air sealing opportunities in the factory, because these were the first 2 boxes to come off the line. And that in and of itself paid for itself. It's not a normal process for a modular build. It took a lot of time. It took a lot of effort, took a lot of schedule to make that happen. It's not something normal to expect from a modular company to do. It's worth a conversation early on in the process, whether or not they can do it or will do it. It paid dividends to do that. Again, the numbers didn't necessarily equate to the whole building, but we got reasonably assured that when we test the apartments individually, that we were going to get good numbers. Now, we get to the job site. Everybody's nervous about this whole building because what do these boxes sit on? Well, they sat on a podium structure that was site built. There's a whole sub-slab, foundation walls, and a podium platform that was actually multi-level. It was actually 2 levels that these boxes sat on. So they're worried about how those boxes, when they're all married together and married to this site foundation podium structure, how that's going to work. And we did one initial test where we took a stack of boxes. In essence, it was 4 apartments, 8 boxes. So it was one, what they call a tower portion of the building. And we isolated it at the corridors. And when the boxes were shipped, they had sections of subfloor that were removable because they had to tie in plumbing and electrical connections in between floors. So they opened those up so that the air could communicate from the 4th floor down to the 1st floor. So we isolated this stack of boxes and we did a blower door test on that. We got an okay number. It was nowhere near where we needed to be for a passive house number, but we did a fog test on it and we identified a bunch of areas, and there were some areas that were focused on. There were other areas of the building where we had leakage that just weren't finished, so we chalked that up to being a building in progress, right? But we didn't really have the opportunity to test the entire building until it was 100% completed. All eyes are on it because the project is behind schedule and you know what's going to happen. Guess what? We test the first time, it doesn't pass. And that's to be expected. And again, some advice for project teams. Don't expect your home to pass the first time out, especially if it's the first time for a build team and a design team. It's just unrealistic when you're trying to hit a passive house level of airtightness the first time out. Doesn't matter if you're stick building or modular building. Anticipate failures, okay? They're not the worst thing in the world. They give you an opportunity to fix it. Now, because Lamora was modular built and the interior of these boxes were finished, it made it very difficult to identify leakage pathways because we didn't have open stud cavities to look at, right? We had finished ceilings and all this other stuff. So we used every trick in the book that we could, from infrared to smoke pencils to fog testing. We even had an ultrasonic device demonstrated to help us try to find some leaks. And we identified a number of areas. Some of it was attributed to marriage walls on the interior. Some of it was the interface between the boxes and the podium structure. Some of it was the site-built towers, like for the stairs, storefront windows that were not part of the modular. They were part of the Phius envelope, but they weren't part of the modular build. These were custom storefronts for entrance doors and lobbies and things like that. So we found a bunch of small stuff, and all methods were applied. Caulk, trigger foam, aero barrier, all of the above was applied. Now, I want to put it in context because this is where the verifier, at least myself, became somewhat of a therapist for those on the job site. All the sad faces, disappointment, and anger about failing the test. This particular building, we had to have about 3,200 CFM 50 to get us to the passive house number, okay? First time out testing, we were about 7,000, a little over 7,000 CFM 50. Okay, so double the amount, right? Oh, how horrible. We were half what the code required. If you used the whole building test method in the commercial code, because this building fell under the commercial chapter of the IECC, they wanted 0.4 CFM per square foot at 75, right? If you look at the shell area of the building, that's what the code tells you. To use a blower door to validate the air barrier for a commercial building, at least in New York, it was 0.4 CFM at 75 pascals. We were well below that, okay? I said, you guys never did a blower door test before, and you beat code by a mile, and you're merely double the Phius. That's not a bad place to be. It's going to take a long time to fix this, but you're in a good place. I didn't classify it as a gross. And we found some pretty big bypasses. We had a trash chute that we had to deal with that had a concentric tube at the top that had daylight around it. Nobody saw that. So some of the things were easy to fix. Some of the things were a little bit more tedious. And over the weeks and weeks, we finally got the number down. And not only down, but under by a comfortable margin. So we were like 0.052 or something like that. So an achievement for sure. And I don't think build teams really appreciate it until they go through the process. But certainly the fact that this is a modular box build made it that much more difficult. Because everybody asked the question, well, what about aero barrier? Couldn't you bring aero barrier in? Yeah, we did bring aero barrier in, but it's only effective when you have exposed walls to get the aero barrier too. When you have cabinetry in the way and finishes, the prep work takes 5 times as longer than the actual application. And the application can only get to certain parts of the building at that point. Now you look at it and we got it. So
thanks to a lot of quality control work and oversight.
It's the old analogy, how do you steer a battleship compared to a speedboat? A battleship, you turn the wheel and it takes a long time for it to turn. And that's what the job of the rater and the verifier is. You don't want to be Debbie Downer on every project, but we're trying to help the team foresee potential problems so that they can avoid them. And we're looking far down the line to say, if you don't do this, this is going to happen. It's going to be really difficult to fix. So fix it now, even if it's not explicitly shown on the plans. We found it, we uncovered it, get it fixed. Because to deal with it after the fact, you don't want to be there. Hopefully people listen. And experienced teams that have suffered through that first project or two, they get it. They understand that. Okay.
That's a really good reason to bring the rater in very early in the project, because you're the one that knows the checklists and knows the failure on other projects. And especially if there's someone with experience like you have. So your recent project that you're working on right now is very interesting as well, right? It's a panelized system, I believe, and it's a straw system. So what is different about that and how do you approach that?
Definitely some pros and cons. So I'll give you the cons first. It was impractical and there was nobody available to go to Maine to actually measure and validate the insulation as it was going in. So we worked with the factory. They gave me a reasonable amount of photo documentation of the materials that they used for framing. It's dimensional lumber, 2x4s, 2x6s, no big deal. But any plywood, any OSB substrates they used, they gave me a materials list, and I vetted that for the Indoor Air Plus program, and everything came out good. Then, as they laid out the framing, it's basically a double stud wall. It's about a 12 or 14 inch, I think about a 12-inch thick, like double stud wall. They sent me photographs of the framing, spacing, and depth of the wall cavity. And then, as they claim it is a proprietary installation method for the straw bale, so they couldn't send me any videos of that. They said that that might change in the future, but for now they had to be a little bit protective of their process, which I totally get and totally respect. But what they did do is they sent me some depth measurements. Fortunately, they were using a fabric WRB to hold the straw in, like a netting material. So they were able to get some depth measurements out of it. So once we saw the framing spacing, and they were actually able to dense pack the panels and give me some depth measurements. And then the key to it was I asked them whether or not they had panel weights with and without the insulation, what you would, like in a cellulose world, a bag count. And they actually did. They had weights and densities of the straw. That was their normal process. And I was like, fantastic. So they sent that to me. The other thing too is once the panels were shipped to the site, the straw wasn't completely hidden. The fabric was still there. The holes were still there. I could take some field measurements if I wished to. And I was able to take some thickness measurements. So the panels, when they're shipped, it's not a finished product. It's a finished thermal barrier product, but it's not a finished house project. There's no drywall on it. There's no siding on it. And so as they set the panels, they're devoid of, you can still verify and validate a lot of this stuff out in the field. I did go up one day when they were setting the roof panels. That was quite neat. The other beauty of it too is that the air sealing details are pretty simple. You put 2 panels together, they put a slight filler strip in between if there's an airspace, like a thin 1/4-inch piece of plywood to fill the gap, and they tape over it. Some of the high performance building tapes. So they tape the vertical seams inside and out. They tape the horizontal seams down to the foundation of the sill plate. They put the roof panels on, the same spacer type of arrangement, and they tape those. And voila, you have a building envelope. It's a pretty simplistic approach, just like any other type of panelized construction. I thoroughly enjoyed that and got it. Now it's just a matter of when they put the windows in and how they tape it. This particular project is being done by a terrific builder. They've done passive house and zero energy homes. My work is merely a formality. They just have to remember to call me to come out and do some of the formal things. Like they do their own preliminary blower door testing. I still want to do mine, but they're in the habit of doing that. They also embedded some moisture meters in the straw too, so they can monitor the wetting potential of the straw and the moisture content and humidity inside there. They're doing some really neat things with this house. For me, it's a single family home, so a little bit simpler than a multifamily. The panelized construction really lends itself to air seal very easily. So it's very easy to validate the air sealing details on site as opposed to in the factory. And there really wasn't as much of a concern about the in-factory QA because I could see the product when they shipped it to the site, as opposed to a true modular build or other types of panel systems that might be finished that you don't get to see when they're shipped to the site.
It seems like there wouldn't be any surprises at the end with the airtightness testing if they're testing all along. Have you done the mid-construction airtightness test?
Not yet. Hopefully within the next 3 to 4 weeks. We insist that they get the house in real, what I call real condition. So windows installed and taped. And again, all those mechanical, electrical penetrations. We want the radon stack, if there is one. The thimble, at least going through the air barrier through the roof, right? We want that installed. We want the plumbing waste vent that goes through the roof. We want that installed. The fresh air and exhaust thimbles for the ERV. We want those installed. The water line penetration, or at least the sleeve going through the foundation where the water line would come in, where the refrigerant lines would go out. We want all of those penetrations installed, taped, and it's okay if they're capped off, but we want to test the integrity of those critical areas. When you test a home that doesn't have the MEP roughing through the air barrier, you're just testing the air barrier. You're not testing those things that typically fail on a home. So we want to test those too, to validate how well they're taped and sealed. And you still have to connect things to them. You might have a sleeve that goes through the foundation. You still have to run your cold water line in. You still have to pack it out and fill it. But you get a pretty good sense of how the house is going to perform. So we're hoping in this house, it happens maybe first or second week in August.
Well, thank you so much for sharing all your experience. And are there any other tips that you want to share besides involving the rater early on?
There really needs to be a very good line of communication between the passive house consultant and the rater and verifier all through the process. Certainly through the design review process. We mentioned having the rater and verifier doing their design review, their plan review prior to submitting to Phius for a design review, and having an open line of communication during the build between the rater, verifier, and the passive house consultant. That way, as changes come up or issues come up, they can be evaluated. If you have a good line of communication, they can be evaluated pretty quickly. And I'll give you a couple of quick examples. You might have a floor assembly. You might have an exterior assembly, doesn't matter what it is, that has continuous insulation on the outside, and it might have cavity insulation on the inside. And sometimes the insulator comes in, thinks you're doing the right job, or maybe the detail is drawn in such a way that it's impractical to install the cavity insulation that way. And they may fill the entire cavity with insulation, thinking that more is better, right? Not necessarily in the passive house world. We have these moisture risk guidelines in the Phius guidebook where you have to have a certain percentage of exterior insulation versus interior insulation in terms of R value to mitigate that moisture risk. And certain assemblies are more vulnerable to moisture and not as easily able to dry out. So you may have an issue where either an insulation material gets substituted or more insulation inadvertently gets installed that needs to be evaluated like right then and there before it gets closed up. That's one of those examples where good communication between the passive house consultant and the rater needs to take place. There could be an equipment substitution. There could be a window substitution. With all the best intentions, but if it's not run up the flagpole vis-a-vis the energy model, you might be in serious trouble at the end. And by the way, it's the rater and verifier that submits the project for final certification. We're the ones that put it in queue for that certification. Another kind of pro tip is that there are actually 3 formal reviews that take place for a final certification. One is a QA document review. So the certification team will actually take a look at the documents that are submitted by the rater and verifier to make sure that they're all complete, everything's there. They're in the right folders in the Phius Dropbox folder. If something's missing, they're going to take it out of queue, send it back to you and say, we need X, Y, and Z. It might be a certificate for a piece of HVAC equipment. It might be an energy guide for an appliance. There might be a photograph. Okay, so that gets vetted. Once that's completed and up to par, then they'll go through the official quality assurance review and they'll review all the materials that the rater and verifier sent. Does the design match up to what was verified in the field? Does the blower door test look like it's valid? Do the model numbers line up with what's on the plans? Once that's done, then it goes into final certification review. And if those 2 pieces are done well, and the rater and the verifier have done their job, and things are clear and concise, then the final certification review is the easy part. Because then all they're doing is just updating the WUFI model with those field conditions, putting the power in. There might be a little tweak to the final installed R value of the insulation, putting the blower door number in, and then the certification goes smoother. So the better a job a rater does with that information when they upload it, the quicker the review will take place, the smoother it will go, the less rounds of feedback. That type of rating that you do for Phius, it really needs to be one of your best ratings that you're going to do. Dot the I's, cross the T's.
Well, that's a great tip to end on. We really appreciate your time and your expertise, and thanks for coming in to talk to us.
My pleasure. Anytime. Thank you. Again, an honor to be talking to you guys. Thanks very much.
And that was Tony Lisanti from Integral Building Design. There's a lot going on there, Mary. He's a busy guy, and bit of a trip down memory lane and some history, talking about HERS, Energy Star, kind of where not all of them, but a lot of these ratings started. And I found it quite interesting hearing all those names and those acronyms, and then some new ones that I hadn't heard of before, not just the net zero, but also air quality. I found really interesting that there are sort of ratings for that, and then also all the other QA and QS processes. Quite a lot going on there. What were the big outtakes for you?
Well, I thought he gave such a great, as you say, laying out of the history, and then just so specific on the Phius rater processes, the Phius verifier processes, and the great pointers about what to do to make sure your project goes well and smoothly towards certification. It was really, I very much appreciated how specific he was.
Mm-hmm. I hadn't really thought about it, but there are probably a lot of passive house consultants out there, particularly in some of these larger organizations, that sort of get handed a job to maybe do the PHPP and do some recommendations, but then don't see the project again, or certainly don't see it on site, and probably hopefully know how it went. But there's a lot of other stuff that goes on at the assessment stage. So that's a good reminder of, I guess, the importance of being involved with the project as early as possible, but then also kind of seeing it through. And the other key thing is getting that certifier on board the project. I think the name is a little But I mean, it is a certifier, and so, normally you sort of package everything up, and you don't see the certifier until the very end. But all the certifiers that I've heard from and talked to are very keen to be involved in the project really early on, because they want to check everything is going to be run smoothly right from design stage, and they'll be able to know what it's how likely it is. I think his story about the blower door test is a good analogy of that, because as he says, the blower door test shouldn't be a surprise. If you know how everything's gone, you've done a mid build test, and you've really looked at your quality assurance, then that end shouldn't be necessarily a big nervous. It always is a big nervous test, but you know what I mean. It's and that should be the same for the design. If the certifier's there and they can identify where things might go wrong early enough, that can make a huge difference to the project outcome.
Right. He really emphasizes that the rating and verification processes are not something that happens at the end. It's something that starts at the very beginning of a project. And, he, as you said, he gave some great examples of the things that you can miss, like how the vapor barrier details on the ductwork connect to the vapor barrier in the house. I mean, that's really specific, really specific information that you need to think about in the beginning of a project and not at the end of a project. Otherwise, you're just not going to make that certification.
Well, and also at stages during the project as well. It's that constant attention, because I know there are, with the air tightness of vapor barriers in a multi-story building, there are really important connection strips that, if they don't get put in at the right time, that can create a lot of work to then retrospectively do a bunch of origami to try and make the air tightness layer be continuous up through a floor plate or something like that. Whereas if you sequence it properly, that just saves a lot of heartache later on. And there are lots of examples, similar examples of that. So that's comes back to that quality assurance, and I think that's part of the value of having certification, whether it's Passive House, but all those other ratings. They quantify the performance, and I come across this a lot at my day job, that I think that the general consumers believe that a building built to code is sort of quality assured. Like that, I think that the code is a quality assurance check, and it's not really. I mean, it does check some things. It checks the sort of basic structural safety, well, at least it should. But it doesn't check the airtightness necessarily, not in our part of the world at all. Doesn't necessarily verify that the ductwork is working and installed properly and commissioned properly. There are so many things that don't necessarily get checked unless someone is paying attention. That's one of, I think, the real value of certification.
Right, that you get a second set of eyes on what's being done, right? Because also a lot of people assume that builders know and fully understand the implications of what they're doing, when, as we know, that's so often not the case. So yeah, it's really important. And and he's doing Phius verifying, Phius rater work that's, I'm sure getting a great discussion at the conference right now.
Absolutely, yes, definitely, and always good to hear from certifiers, and I'm sure lots of people will benefit from more of those stories. And as you say, the PhiusCon is happening at the time of the release of this episode. Looking forward to hearing back from Zach and Ilka and the rest of the team from their time there. All right. Hey, well, thank you very much, Mary, and thank you to Ilka as well for bringing us that interview. We've got more interviews and stories coming up, so be sure to check out the Passive House Accelerator and, of course, Reimagine Buildings. And we'll be back again next week on Passive House Podcast.